Electricity can be confusing. Volts, amps, resistance, transmission lines, distribution transformers. What does it all mean and how are we supposed to think about it? Because for the average person, it's very difficult to understand something that we can't see. So let's put it in comparable terms with something that we can see. If you want to think about what happens when electrons run through something like this, basic household light switch, then think about it in terms of water moving through something like this. That's right. Water is an excellent comparison for electricity. Let me show you how. If you need a large volume of water to fill a swimming pool or to put a house fire out, you have to have large volumes of water, but you don't necessarily need a lot of pressure because it's going a short distance. That large volume or small volume equates to the current, or the amps, in electrical terms. Conversely, if you have to move electricity a long distance and you need high pressure, think of it like a pressure washer, cleaning your driveway or the side of your house, where you use a little bit of water at a very high pressure to do the job effectively. This can be compared to high voltage transmission lines that you see scattered across the countryside. Big steel towers with wires on top of them. Well, they're like that because they have to move that electricity a long distance, and therefore you have to have a high pressure or a high voltage to get it there. So if you have to have high pressure or high voltage, that's those large transmission lines. If you have to have high volume, or any volume for that matter, and you don't need a lot of distance, you can think of it in terms of, once again, a garden hose versus a fire hose versus the water that flows over a dam. Different volumes, different pressures, depending on what you need it for. Now, one last thing I want to talk about here is resistance. So you hear the term resistance. What does that really mean? Well, if you think about it in terms of water, the water comes in here and then goes here. It hits this corner and it slows down. It's inefficient. So it slows down before it goes this way. That's a form of water resistance. Same thing in electrical terms, but we use it in many ways effectively. So think of a toaster where you put the electricity in, it goes to the element, it gets red hot, it generates a lot of heat, which is not good if you want to transfer that electricity through the toaster, but it's very good if you want to use that heat to cook your toast. I hope this has been helpful. If you'd like to learn more, please get in touch with me. I'm Keith, I'm with Accepted Utility Strategies, or check us out on YouTube. The link's in the comments. Have a great day.